Hello everyone, this is Sciencehead from Sciencehead channel. I believe that you're watching this video because you're interested in quantum physics, and that is awesome. This video is the first part of how quantum physics began, and it is made for people without any previous knowledge regarding quantum physics. I promise that you will not be confused at any point. However, if you have any difficulty understanding the video, or if you found any wrong information, please feel free to leave a comment. Lastly, please subscribe and like, and let's begin. You have probably heard of the term atom. It is an extremely small matter that acts as a building block for everything. Then, scientists have been putting a lot of effort trying to figure out how the atom would look like. However, as I said, because atoms are basically the smallest thing in the world, scientists were not able to observe atoms just by using microscopes. Thus, there were only a lot of theoretical models existed. So back in the time, a guy named Bohr established the Bohr model as a prediction of basic structures of atoms. Because there were already several experiments for determining atoms' properties, and there were also previous models for atoms, the Bohr model was basically a composition of all pre-existing knowledge. There were something called protons and neutrons, and electrons orbiting protons and neutrons in the middle. If you're not familiar with those particles, do not worry. You just need to know how they are all components of atoms, and protons have a positive charge and electrons have a negative charge. Thus, because they have charge, they are unstable, so protons and electrons are attracted to each other, just like magnets. Now you know that protons and electrons attract each other, Bohr model might look weird. If protons and electrons really attract each other, how can electrons orbit protons without colliding with each other? So, after a scientist named Louis de Broglie published matter-wave theory, meaning electrons have a wave-like property, Bohr's model could also be explained. This discovery was very significant, as it was believed that all electrons would have a particle-like property since then. Thus, a lot of phenomena could be explained through matter-wave theory, and proved a lot of things including the Bohr model. If you're not sure how an electron's wave-like property justifies Bohr model, think of a guitar string. If you make a ring with a guitar string and flick it, it'll constantly move while the size of the ring does not change. Anyway, after the Bohr model was proved with the matter-wave theory, a lot of scientists liked it and agreed with it. However, there was a still challenge remaining for the scientists. Scientists wanted to prove this phenomenon, how electrons have wave-like characteristics, using mathematics. However, in order to use mathematical equations, they needed to know the initial location of the electron with its speed while electrons constantly move. Unfortunately, since it was only possible for scientists to gain an initial location, or electrons' instantaneous speed, meaning speed right at the moment, scientists were struggling to prove the Bohr model mathematically. Suddenly, a guy named Heisenberg, who was a student of Sommerfeld, got a chance to meet Bohr. Then, Bohr noticed Heisenberg's talent and offered Heisenberg to work with him. Of course, he accepted the offer, and while working Bohr's lab, Heisenberg came up with a conclusion on how the location of an electron is indescribable. Instead, the only way to depict the world of electrons is to use a measurable quantity, e.g., which humans can actually see. Thus, Heisenberg used the fact that electrons emit color when they move around different locations of the atom. So, here's an easy example for the method that he used. If Superman flies as fast as light, we cannot see exactly where he is. However, if we see red after image, there's about 2.4% of possibility that it's passing through Rocky Mountain at speed of 20,000 km per hour. And if we see blue after image, there's about 5.7% of possibility that he's passing through the Great Lakes at speed of 45,000 km per hour. Obviously, the probabilities and speeds are really off, but calculation was based on the color of the light the electrons emit, just like a previous example. Despite being only 23 years old, he eventually used matrix mechanics, which is one of math technique, in order to prove the Bohr model. Note that he used how electrons have particle-like properties, not wave. After this method was published, the majority of scientists loved it. However, there was one genius scientist who was not in favor of this type of proof: Einstein. And that is it for the first video, and the story will continue on the second video. Please feel free to leave a comment, and please like and subscribe if you haven't done it yet. I hope you have enjoyed the video. Thank you very much.